Hello and welcome back. This will be section 3.1, and it's called complex numbers. This is in the course of chapter 3, which is polynomial functions, and we're talking about complex numbers because of the next section, quadratic functions. This is when mathematics gets really interesting. Complex numbers, you technically won't really delve into it until Calculus 2, in chapter 10-ish or something, when you start doing things called polar coordinates. But for us, right now, we're going to talk about it just for this section. And I like it because of two things. One, its importance. In terms of mathematics. All science is done in the complex plane, which I'm going to define in a second. And then two, the algebra. If there's anything you can do in this course, this semester, is get better at algebra. Hone up your algebra. Working with complex numbers will help you do that. Okay, so what we're doing today, we're going to define them, and I'll talk about it here and there, and then operations on them. We add, subtract, multiply, divide complex numbers, and then that's it. I don't know how long this will go, but because it's theoretical. I mean, this is as theoretical as she gets. Here we go. Here is, whoops, oh well, f of x squared plus 1. And that's a picture of it. And you say, okay, well, that's great, but however, we mathematicians are interested in being able to solve every algebraic equation. We want to solve every equation. That means set it equal to 0 and solve it. X squared equals -1. X equals the square root of -1. Definition. There's we're defining this number. I mean, we're making it up. You can think, but pull it out of thin air. We call it I. Is the square root of -1. And from there, we build a whole system. There's a definition. There's a number I. It's a number. Just as much as 2 is a number, and 17 is a number, and pi is a number. This is in the complex plane. So I is defined. And then the complex plane works like this. The plane. The complex plane. And, by the way, much as we denote real numbers, C with a, yeah, something like that. That's how you denote the complex plane. And it's much like the coordinate plane. Instead of having a real number system both ways, keep in mind, y's and x's, this is the real number systems. And it will be in the complex plane, by the way. This is also a real number system. However, in the complex plane, this is the imaginary part of a complex number, and this is the real part of a complex number. And so we say, okay, so how does that work? I is the square root of -1. Right there's the point I. Here's 1, by the way. This is 1. 1, 0. Right there. So, yeah, what happens is we use this plane to plot points. For example, there's a complex number. Call it 2 plus 3i. Well, the 2 part is the I'm getting ready. The 2 part is the real. 1, 2. 1, 2, 3. That's a point on the plane. 2 plus 3i. And on and on. That's the origin. Here's -1 rather. In the fourth quadrant over here, this would be 3 and -5i, something like that. E plus pi I is. Just want to put this up here. E to pi I plus 1 equals 0. This, again, you won't see in this class, but that's where you head. This is the most important equation in all of number theory. And here's a picture of it. just like that. This is 1. Here's e to the pi I. Plus 1 is 0. Okay, that was an aside. But that's the complex plane. I mean, things are important in science. Security, I'm sure in security, they're not working in the real plane. They're working in the complex plane because you just add dimensions. You can add different dimensions using the complex plane. And certainly the theory of relativity, mathematics, has grown quite a bit because of this discovery, invention. Okay, so that's a little bit about it. Right there, this is the reason we're doing it, because next chapter, next section should be, by the way, a review for you. It's quadratic functions. It's, x squared stuff. But because we're going to get a quadratic formula, you could have a negative under there. So that's why we're doing this particular section. Okay. Let's go to multiplication. So you can operate on these things. Operations. Meaning add and subtract. Now, I'm not going to spend time on this at all. Add and subtract, because it's pretty simple. A plus bi. Suppose that's a complex number where a and b are this is the real part. This is the complex. It's also real. B is a real number, but bi is the complex part, or the imaginary. And I'm going to use a plus bi and then c plus di quite a bit just for this theoretical discussion. So if I add a plus bi plus c plus d, you get the real parts. You add them up, plus b plus d. And that goes for subtraction as well. If I could add them or subtract them. Oh, and then this would of course be a method. Just add, I guess 2 plus 5i plus 3 minus I, something like that. 2 plus 3 is 5 equals 5 plus minus 1 is plus 4. Just adding them. You can add, subtract, and then multiplying them. It gets a little bit more intense. And then dividing them. That's what we have to talk about. The most is dividing them. So multiplying them. Oh, no. Let's start with multiply by a constant. A real number, c times a plus bi. Now that's pretty simple because it's ca plus cbi. 2 times 4 plus 1 plus 3i is 8 plus 6i. Simple. When you multiply two complex numbers, this is when it gets a little bit, you have to think about it, because you're foiling now. These are binomials. And in order to multiply this out, you have to FOIL. Remember FOIL? First, I don't know how you, outside, inside, left, whatever. I don't even know if you know this acronym, but please get to know how to multiply two binomials. So I'm taking a times c. First is ac. Plus outside is ADI, plus inside is BCI. And then last, now here's where it gets interesting, would be BDI squared. That's why all this is happening, really, because now, hey, check this out. Let's do this. AC plus, I'll add these two. AD plus BCI. But now, here I want to think about that. Since I squared is negative 1, this is a negative 1, so that's a minus BDI. Minus BD. So the real part comes from the AC, of course, but it also comes from the last. First and last are the real part. Outside, inside are the imaginary part. So this is actually AC minus BD. That's the real part. and then plus the imaginary AD plus BCI. And I'll do an example, and I think we'll stop there. Yeah, I'll do an example, and then I'm coming back to talk about division. Just one example of multiplication. I wonder if I have one. I can just make it up again. Well, there's one in the book. I have one in the book. 2 plus 5i, 4 minus I. Nope, that's division. Whatever. 2 plus 5i times 4 minus I. Multiply. Sorry about that word. Multiply these two. Okay, so, whether or not you choose it, you like this acronym, you even know this acronym, FOIL is a great way to remember how to multiply binomials. You need to do 8 minus 2i plus 20i minus 5i squared. And here's the important part. That's negative 1, which changes this sign to plus 5. 8 minus 2 plus 20 plus 18i plus 5 is 13 plus 18i. That is the product of these two numbers. Notice this is a point and that's a point. We just multiplied 2 points together to get a third point. That's the power of the complex numbers. Hey, I'll be back. We have to talk about division. Thank you.